Number 1.
Ants are fascinating insects. They communicate with each other and coordinate both their actions and movements. Each ant makes its decisions autonomously, but in doing so is subordinate to the common objective and thereby plays its part towards solving the task in hand. The delicate ants are therefore a real challenge for the Festo engineers when it comes to transferring role models from nature into the world of technology. For the first time with the bionic ants, the behavior of ants is imitated using complex control algorithms. In this respect, it's not about a technical game for the Festo engineers, but about nothing less than the production technology of the future. In the world of Industry 4.0, machines also have to communicate with each other, make autonomous decisions and cooperate in order to be able to react flexibly to different production scenarios. The biggest challenge for the Festo engineers was to integrate all the necessary functions of an artificial ant into the smallest of spaces with as few components as possible. Our engineers overcame this challenge. Enough space was created for the rechargeable battery and room for the eyes was made in the ant's head. Such a functionally integrated design is made possible thanks to 3D printing. It would be difficult to make such an ant using conventional production engineering. 3 piezo bending transducers are used on each leg. Coated on both sides with piezo ceramics, they are able, depending on the electrical controls, to deflect by 1.5 millimeters in both directions. Clearly not enough to get an ant to walk. With the help of an elastic hinge, the Festo technicians have managed to increase the ant's step length to over 10 millimeters. The benefits of piezo elements are impressive. They work on little energy, are almost wear resistant and can be controlled quickly. But how does a small ant robot learn to walk? The motion sequences of the ant are programmed and tested on a computer. If the ant walks smoothly on the computer, it must demonstrate during initial tests on the real model how well it can walk with its 6 legs. Taking into account that this bionic ant has only just learned to walk, it gets around really quickly. Using a 3D camera system which was developed by scientists at Delft University and adapted to the ant by Festo engineers, the ant is able to see. Combined with an optoelectrical sensor, the bionic ant manages to find its way round in the space. How does the ant determine its position when it's on the pitch? Well, for this we actually use 3 sensors. First of all, we have a mouse sensor here under its abdomen. The mouse sensor is actually the same as in a computer mouse. We can use this to track where the ant walks across the pitch. We also have a magnetometer here in its head. The compass actually shows where north is, and with this we can determine what direction the ant is headed. Here at the front we also have a camera system consisting of 2 cameras, which gives us a stereo image and means we can detect the markers on the pitch and also measure the distance to them. We can therefore position ourselves with complete accuracy on the pitch.
Number 2. Number 3.
This is Matt and I'm Jay. We are the developers for the next generation in microflying robots called the Dragonfly.
For hundreds of years, man has looked to the sky to fly like the birds. Our inspiration comes from one insect in particular, the dragonfly, with unmatched flight performance in the insect world. The TechJet Dragonfly is a lightweight robotic insect that collects and relays information while flying like a bird or hovering like an insect. Weighing in at less than 1 ounce, approximately the weight of a AA battery, the Dragonfly is the latest in ultra-micro avionics with stereoscopic vision, flight control systems, and a camera-ready operating system. This means you can do amazing aerial photography, spy on people, secure your house, or use it as the next-gen gaming platform. We've all seen helicopters, we've all seen quadrotors and airplanes, but really, all of them are bulky, low on battery, and really just a one-trick pony. The TechJet Dragonfly is really in a league of its own. It hovers like the best quadrotors and helicopters. It flies like the best of airplanes. It's really all these different flyers combined. The Dragonfly gets smaller and smaller with each iteration while enhancing its performance, something physically impossible for all the other flying systems. What you have is the world's first aerial photography tool that's efficient, user-friendly, and you can take it in your pocket wherever you go.
I got my PhD in robotics and artificial intelligence from Georgia Tech, and I've been pursuing my passion for designing the next generation robots for the past 10 years, winning numerous competitions, patents, awards in robotic systems.
I'm a graduate student in mechanical engineering at Georgia Tech, with focus on mechatronics and automation. The research behind the Dragonfly began with a $1 million grant from the U.S. Air Force. The Dragonfly has been developed at Georgia Tech as a joint effort between PhDs, graduate students, researchers, and professors from multiple universities across the world. The Dragonfly has 5 technology patents on its design, ranging from mechanics, aerodynamics, and flight controls. The Dragonfly is a game-changing technology and has won numerous awards, including the Best Design at Georgia Tech Research and Innovation Competition and first place at Robotics Innovation Competition in Massachusetts. Unlike most other flying vehicles, the Dragonfly is highly modular. You can upgrade all the elements of the robotic insect through our website, from actuators to wings to electronics and many more. You can make it faster and more dynamic for gaming, or higher endurance and more stable for aerial photography. We offer 3 different electronics packages, ranging from basic flight control using gyroscopes and accelerometers to more advanced packages, which include GPS, high-definition video, multiple cameras, and wireless communication. The packages are the lightest in the world, going from 3 up to 5 grams, weighing less than a quarter, and are smaller than a stick of gum. The system is quite user-friendly and can even be flown with an iPad or smartphone. We offer all SDK to take your already awesome flying insect to the next level. With 20 environmental sensors, cameras, and GPS capabilities, it can be developed to track athletes, outdoor events, or integrated with an app as a fun way to record and retrace a day of skiing, hiking, or whatever you like. As a home security option, the Dragonfly can hover, monitor, and report from inside or outside your home or property. The military can benefit from compact flyers, given that each soldier has a look ahead. Having the Dragonfly as a pocketable tool for the police can ensure rapid response to stop violence in time. This could be the next generation in spy tools. Even James Bond would want one of these in his pocket.
Number 4. Number 5. Number 6. Number 7. Number 8.
So the general goal of our lab is to understand the locomotion aspect of animals. And recently we are focusing on quadruped, four-legged animals. And we try to understand how they efficiently run on the field and nature so that we can take that inspiration and then use in our engineering world. So for example, we can create a prosthetic legs out of that technology, or you can even make a new transportation replacing cars so that you don't need a road in our world.
Cheetah is the fastest four-legged animal in the world, and then we would like to make our robot run fast like a cheetah. When we started to build our robot, we started to look at Cheetah's motion and applied its principles to our mechanical version of Cheetah. Currently, our robot Cheetah can run up to 10 miles per hour and jump over 33 centimeter high obstacle.
So previously, most Lego robots are powered by internal combustion engine and then hydraulic transmission. And those are very noisy and very inefficient. But people believe that internal combustion engine and hydraulics are only way to make a Lego robot runs and support itself. People believe that electric motors are not powerful enough. So this is the first time we shows that electrically powered robot can run and jump over foot-height obstacles.
In order to build a dynamic robot like a Cheetah, we had to develop everything on the robot, including motors, control system, and control algorithms. Because previous robot technology is focused on controlling static motion of the robot.
I think this is a really exciting future where robot can be quiet and efficient and also powerful, and then we might exceed the muscles performance in the future.
Please don't forget to like and subscribe for new videos every day.